Hi guys, this is Miss Auday again. Welcome to Algebra 2 General Child's High School Section 6.6 Function Operations. This is part 2 and it will be done in 2 videos. So this is day 2 of 6.6 Function Operations. It will be done in 2 videos. And then after the 2 videos, I will give you your homework assignment and then your upload assignment. All right, so we're going to get started. A composition of function is what we're doing today. So if you look at the box in the right-hand corner, this is called a composition of functions. It has this little circle, open circle, in between the f of x and the g of x. And so this is very different than the function operations that we did on day 1. So a composition of function pretty much tells you that you're going to be substituting. So what are you going to be substituting? You're going to take your g of x in this problem and you're going to substitute into your f of x. That's why they wrote it to the side another way. You take your g of x and you substitute it into your f of x. All right. So for the next one, you take the f of x and you substitute it into the g of x. So here's another way of writing it. Take your f of x and substitute into the g of x. So basically, whichever function is closest to the x is the one that you start with. It's not the one that's in the front. It's the one that's the closest to the x. All right. At your favorite store, you're such a loyal customer that you have a discount that always gives you 10% off your total price. So we're going to write an equation for f of x that represents 10% off. All right. So f of x equals, let's let x equal our purchase price or our original price, whichever one you want to write. All right, and if you think about it, when you get 10% off of something, you're only paying for 90% of that item. So my f of x is going to be 0.90 times x. All right, you also received a special coupon in the mail that takes $10 off any purchase price over $10. Write an equation for g of x that represents the $10 off coupon. So I'm going to take x and I'm going to subtract 10 from it. Now, I have to make sure that I realize that x has to be greater than 10 because if it's not greater than 10, I will be paying $0 for something, and that doesn't ever happen. All right, so now let's put this into use in doing a composition of f of x and g of x. So since the g of x is closest to the x, you're going to take your g of x, which is x minus 10, and you're going to substitute it into your f of x. So you're going to substitute that where you see x at. So you're going to put it right there where the x is that I'm circling. So it's going to be 0.90. I'm just going to put 0.9 times x minus 10. Now we're going to distribute. That's 0.9x minus 9, because 0.9 times negative 10 is negative 9. All right, let's look at the next one. We're going to do a composition of g and f of x. Now notice f of x is closest to the x, so that's the one we want to look at first. So f of x is 90% times x. I'm just going to put 0.9x. So we're going to take that 90% times x, and we're going to input that into the g of x problem. So what is g of x? Well, g of x is x minus 10. So you're going to put the 0.9x where you see the x in the x minus 10. So it's going to be 0.9x minus 10. And we don't have to do anything to that one. That one's ready. So does it matter which order the discount and coupon are applied? Yes, it does. It matters very much. So stop writing and just watch. You don't have to write this part. If I went to the store and bought something for 20 bucks, 20 minus 10 is $10. And 90% of $10 is $9. So if they took the $10 coupon off first and then took 90% of that, I'm going to pay $9 for a $20 item. Now let's say they didn't use the coupon first. Let's say they did the 90% first. 90% of $20 is $18. And 18 minus 10 is $8. So there's a difference. So which one is the better price? We want to get the coupon second. Or I think a better way of saying that, this is when you want to pick up your pencil and write. We're going to put, let's get the discount first, coupon second. So, is a composition of functions commutative? That means doesn't matter the order you do it in. Like if you commute, you go from school to home and from home to school. It's the same distance. Are the functions commutative? Does it matter the order you do this in? It matters the order. So no, they are not commutative. You cannot do them in any order you want and get the same answer. All right, so let's put this to use with some function equations. All right, so we're going to do two compositions. And I'm going to stop the video now and go ahead and go to the second video because I don't have enough room on my screen to do this. So just stop this video and go ahead and go pull up the other video now. Alrighty, and I'll see you in a minute. Thanks.